Jai Hind all, myself Amita Asthana. In this video we will study some concepts of shifting and scaling of the signals. Earlier we have discussed that whenever we shift the signal, we need to take care of the right shifting and the left shifting. See, if we want to calculate for, let us say, this signal, a signal we have considered as xt. This signal is from -1 to 2. This signal takes this triangular form. I need to draw the signal that is x of t minus 2. So, it is clear that whenever we need to draw the signal xt minus 2, we shift it towards right. That means we need to shift the signal towards right. Okay. And whenever in the earlier video we have discussed that whenever we calculate xt plus 2, we shift the signal towards left. Now we need to prove it mathematically how it is coming. I told you in the last lecture that about the procedure. Now we will see how we mathematically we can calculate the shifting of the signal. So coming for this, we consider a signal yt that is equal to x of t minus 2. Now I will take different values of t and will see the values of yt and x t minus 2. So we start here that let us consider t is equal to 0. So for t is equal to 0, my y0 is equal to x of minus 2, and that is equal to x of minus 2. If I see here, then this is equal to 0. Similarly, I will take some another value of t, let t is equal to 1. Then for t is equal to 1, I will calculate my y1, and that will be x of 1 minus 2 which is equal to x of minus 1, and that is equal to, from this we can see that this value is equal to 0, right. Similarly, I will take some more values and check the values, like t is equal to 2 and my y2 is equal to x of 2 minus 2. So that will be x of 2 minus 2, and that is equal to x of 0, and from the graph I can say that this x of 0, if I see, that takes the value of 1. So here that is equal to 1. Some other values we may also check, that is for t is equal to 3, my y3 is equal to x of 3 minus 2, and that is equal to x of 1. And if I go to my graph, then I can say that this 1 is some value x of 1 that is in between around 0.5. So that's the value which I can write here, that it is as 0.5. Similarly, I can go for some another values like t is equal to 4, so that I can be very sure about my graph that t is equal to 4 and y4 will be equal to x of 4 minus 2, that is equal to x of 2, and the value is from here, as I can see that the x of 2 is equal to 0. So here it is again 0. Now I need to draw my graph. So I will draw it for t, that it is 0, 1, 2, 3, 4, okay, and 5. Let's say here the value is 1, let's say, and here I am drawing the graph for y of t, which in turn is equal to x of t minus 2. One by one I will check all the values. For let's say t is equal to 0, my value is 0, so I can mark it here as for t is equal to 0 my value is 0. For t is equal to 1 I will check, the value is again 0 here, and then at t is equal to 2 my value is 1. So this value is 1, and for t is equal to 3 my value is around between this 0.5, and for 4 this becomes 0, and hence if I need to calculate for t is equal to 0, 1, 2, 3 and 4, then I can say that this minus 1 to 1 for this 0, which is equal to here xt is equal to 1 for t is equal to 0, and here it is 1 for t is equal to 2. So here this value is 1. So what I can do is that here it is 0, so I will just combine my all the values and I will draw my graph. Here it is the minus 1 to 0, that is 1 unit distance, and from 0 to 2 is this 2 unit distance. So I can say that here I will start my graph from here and I will take the value like this, and here as we can say that this graph is now for x of t minus 2. So this x of t minus 2, let us check the graph. Coming to this point, see here this graph was defined from minus 1. This point is now at 1. This point which was at minus 1, so I have shifted my graph to 2 units in the right side. Similarly, whatever value was at 2, now it is at 4. So the shift is 2 units, very visible from the graph. So in this way we can mathematically solve the shifting of the signal by using some simple manipulations and just putting the different values of t, and the procedure is we will just assume one more signal that is defined as yt. Now again let us see the scaling of a continuous signal. So in the scaling of the continuous signal, as we can see this x of 3t, this is my graph for xt, and this x of 3t I need to know. I need to draw the graph of the signal which is defined as x of 3 into t, where xt is given. Now what next we need to do? For this graph x of 3t, we will again take some signal that is equal to y of t. Again I will put some different values of t and then I will see what the value of yt comes. So the method will be same and in the similar way I will calculate. So let us calculate for t is equal to 0. For t is equal to 0, my y0 is equal to x of 0, and from the graph I can see that x of 0 is 1. Right here I can see that this x of 0 is equal to 1. Similarly, I will take t is equal to 1 and I will calculate my y1, that is equal to x of 3, because x3t is equal to yt, and here I can say that this x of 3 is 0 from the graph. But some values are here for which I can see that my values are 1 also. So for 0 it is 1 and I need to take some value between 0 and 1, because if I multiply it by 1 by 3 it will give me at x1. So here what I can do is I can just take the value to be t is equal to 1 by 3 and that will be equal to t y1 by 3 and x of 3 into 1 by 3, and that makes x of 1, and this x1 is 0.5 from the graph. Similarly, I will check some more values for this particular. Now I will check for 2 by 3. Why 2 by 3? Because the function is defined at x2. So I will take t is equal to 2 by 3 so that I can get the value of x2. So similarly, for t is equal to 2 by 3, let us say my y of 2 by 3 is equal to x of 3 into 2 by 3, and that is equal to x of 2, and this in turn equals x of 2 is equal to 0. In the same way I can check for more values. T is equal to 2, let us say. For t is equal to 2, y of 2 is equal to x of 6, and that is from the graph I can say that this x of 6 is 0, because x is 0 after 2. Now we have calculated enough of values by putting different t. Now let us draw the graph at this point. We need to define in the more precise way the t values, and here this is my yt, which is equal to x of 3t, and I will mention all the t points which I have taken. So I will take 0 point, I will take 1 by 3 I have taken, some 2 by 3 point I have taken, and then 1, and then 2 and 3, and so on, like this. So in this way, if I take all the values and draw, see x of t is equal to 0, that is 1. For t is equal to 0, the value is definitely it is 1, and for t is equal to 1 by 3, it is 0.5 here, somewhere here it is lying, and for t is equal to 2 by 3, it is again going to be 0, and at t is equal to 0, that is equal to 1. So if I need to draw my graph, that I can say that whatever the values are here, minus 1 by 3, if I want to take that minus 1 by 3, that will be equal to minus 1, and x of minus 1 is again equal to 0. So I can take here this minus 1 by 3, this value is going to be like this. That means now my range is defined for 1. 2 by 3 plus 1 by 3, the total range is 1. And in this way, if I can draw on the same platform as from minus 1 by 3 to 2 by 3, so here if I just want to draw my signal, that is somewhere here I can take my minus 1 by 3, and here I can take some 2 by 3, and I need to draw my graph. So here I can see that the graph has been compressed. The graph has been compressed in this way, and whenever I have scaled by some value which is greater than 1. So here 3 is greater than 1, and hence the compression of the graph takes place. So that's important, that whenever I am scaling by a factor which is greater than 1, the graph gets compressed, and I can calculate the graph in this way only. Now look at one more example where two signals are given. First is xt and another one is yt. So we have to solve this particular question by observation as well as some calculation if we want to do. And I told you, whenever I scale by a value greater than 1, the graph gets compressed. Whenever I scale by a value which is less than 1, the graph gets expanded, and in mathematically we can also prove it. Similarly, if I am given with two signals and I want to find the relationship between the two, and I have, by observation I can see that the signal, maybe it has been shifted and it has been scaled also. So as I can see from both the signals, so how I am going to find the relation between xt and yt, that is important. So let us discuss that. So in the same way, as I have assumed that let's say this signal has been scaled by some value a, I don't know whether it is 1 or it is greater than 1 or it is less than 1, and has been shifted by some value k, and I consider the equation like x of a t plus k is equal to yt. So I have assumed that the signal have been shifted and scaled, and it then gives me the value of yt. Now my next step would be, again I will take some values of t, and then I would like to calculate the values of yt, and then I will compare it. So, let us take t is equal to 0. Here I can take t is equal to 0, and this expression becomes x of a into 0 plus k is equal to y of 0, and this is y of 0 is equal to, as I can say that here it is equal to 0. So, similarly, but I need to make some equation. So, I will put some more values of t, and then I would like to make two equations and two variables, so that I can find out the values of a and k, and hence I can find out the relationship between the two. So, let us take t is equal to 2. So, here x of a into 2 plus k is equal to y of 2, which is equal to, see here, y of 2, x of 2a plus k is equal to y of 2, and y of 2 is equal to 1, right. Similarly, I will take some t is equal to 4 or t is equal to 3 and so on. So, and I will check from where I can get my value. Let us say a into 3 plus k is equal to y of 3, and that is equal to y of 3 is no idea what it is. So, I am not interested to make this particular equation. So, let us erase this equation. Wherever I can get my equation, I will take that value of t only. Now, putting some more values of t is equal to 2, we have already substituted. So, we are having this x 2a plus k is equal to y2 is equal to 1. Similarly, I will, if I put t is equal to 3, then this will give me approximately that no equation I will get, so that I can solve these two if I do not know the exact value at this particular point. So, but I know that this y6 is equal to 0. So, I will be more interested in putting the t is equal to 6 at this point, and hence I will write that t is equal to, let us say it is equal to c 6, and then x of a into 6 plus of k is equal to y6, and that is equal to 0. Now, I am interested to solve the variables, that is a and k. Now, for how to find out these two variables. So, if I see here, this 2a plus k is nothing the point of 0, and if I see carefully, this 6a plus k is nothing but the 2 point of xt. So, just writing this, 2a plus k is equal to 0 and 6a plus k is equal to 2. Okay, this 0, 2a plus k is 0 and 6a plus k is 2, and hence I can find out the solution of these two linear equations in two variables. So, just solving this, I can get this 4a is equal to 2, and hence a is equal to 1 by 2, and if I need to solve the next variable, so the k is coming out to be minus of 2a, and that k will give me minus of 1. So, here I can conclude that a is equal to 1 by 2 and k is equal to minus 1, and hence x of a t plus k is equal to yt, x of a t plus k is equal to yt, and I can say that yt is nothing but x of t by 2 minus 1, t by 2 minus 1, and hence I can get the relationship between the xt and yt. Thank you so much.